All right, 10.3, areas of irregular figures. All right, so first thing we're going to talk about is what happens if they give you some type of shape that's on a grid like this, where it's not very clear what the base or the height is. Now, if you really wanted to and you wanted to spend a lot of time, you could use the distance formula or even Pythagorean theorem to figure out this distance and then try and find a line that goes through here that's exactly perpendicular to this line, and then find the distance of that line. Then you'd have your height, and then you do 1/2 base times height. If you want to, you can give that a try. Or the easy way to do this is to just draw a box that touches all the corners of the triangle. And so now we have a rectangle with a triangle inscribed inside it. I don't know that it's still technically called inscribed if it's not a circle, but it's inside it. And now let's just count. 1, 2, 3, 4, 5, 6. So this is 6. 1, 2, 3, 4, 5, 6, 7. So this whole rectangle is 42 units. Now if we can just take away these white triangles, the area of those white triangles, so minus those areas, we'll have the area of the green triangle here. And that's all we really want. So let's do that. This is a 1, a distance of a 1, so I'm going to put a little 1 there. And 1 times 6 is 6, but remember in triangles we cut in half. So this thing has an area of 3. So I'm going to subtract an area of 3. I'm also going to subtract an area of 3 by 6 in a triangle. So that's 18, but 18 cut in half is 9, so another 9. And then I have another 3 by 7 here. 3 times 7 is 21, but if you cut that in half, it's 10.5. So plus 10.5. So again, these numbers here just came from me doing the area formula for a triangle. If you're not familiar with that, you can go back to 10.1. But it's pretty simple. It's just the base times height multiplied together and then divided by 2. So now I should be able to calculate the area of the green triangle. So it's 42 minus 3 plus 9 plus 10.5. Plug that in my calculator, and I get 19.5. All there is to it. Okay, I want you guys to go ahead and try practice number 1, find the area of this green triangle, and then unpause when you're ready to continue. Okay, so I drew a box around it, ended up being 5 by 5, so that's 25. And then the area of these 3 triangles, this was a 1 by 2, so it's 1. This was 3 by 5, so it's 7.5. This was 4 by 5, so it's 10. So I added those all up inside parentheses, so I could just subtract that whole area, all the white area, and I got 6.5. All there is to it. Let's go on to this next part. Now we're talking about composite shapes. Composite shapes are just shapes that are made up of different parts or different shapes. And so we can find the area of a region by finding the sum of its non-overlapping parts. So the parts that aren't overlapping, as long as we cut it up into legit parts, we should be fine. Now I'm going to show you a trick that I like to do with these to make my life easy. I like to literally just kind of sketch out what I'm going to do, what parts I'm going to add up. So let me give you an example. For example, I'm going to go ahead and just make this into a rectangle. And so I know that the area of this rectangle plus this circle, I could write that as, hey, that's a rectangle plus a half a circle. So I'm going to just say a circle divided by 2. I know this is not actually math. All I'm doing here is just kind of breaking down how I'm going to do this. Now, I do notice that there's a triangle missing, so I'm going to subtract the triangle. So now I have kind of roughly got an idea of what my equation is going to look like, or my expression is going to look like, that'll give me the area of this shaded figure here. So let's do the rectangle first. That's easy. It's 6 by 19. So 6 times 19. Okay. Plus, I'm going to add the area of this half circle. Well, if this whole distance is 6, that means the diameter over here would be 6. So this would be 3, and this would be 3. So my radius is 3. So I'm going to add pi, a radius of 3, squared. Okay, it looks like I need to zoom in to write an accurate 3 there. And remember, I'm dividing that by 2 because it's only half a circle. So pi 3 squared divided by 2. All right, now I just need to find the area of this triangle so I can subtract it. So let's zoom in. It looks like it's an equilateral triangle, 6, 3 plus 3 is 6, and 6. So if we count this as the base, we would know that's 6. And so we just need to know this height here. Well, when you cut an equilateral triangle in half, you get 30, 60, 90s. 30, 60, 90s. So we can use our properties of 30, 60, 90s. We can see they already went from the hypotenuse to the short leg. So to go from the short leg to the long leg is pretty easy. We just do 3 times rad 3. And so now we should be able to come up with an expression for the area of this triangle. It'll equal 1/2 the base, which is 6, times the height, which is 3 rad 3. If we simplify this, we get 9 rad 3. All right. So remember, that's because I'm going to subtract that region from my whole figure. So I'm going to say minus 9 rad 3. Okay, let's just kind of simplify this out. 6 times 19, that's 114. 3 squared is 9, so I'm just going to write this as 9 over 2 pi minus 9 rad 3. Now, believe it or not, this is actually an answer. This is an answer in exact form. So I would just write units squared or u squared, however you want to write it. Or I could go ahead and plug all this into my calculator and see what I get. When I do that, I'm going to get an approximate answer, and the approximate answer I get is 133.33 units squared. So either one of these are acceptable answers, just depends on how they ask for it. All right, let's go to the next page. Okay, so this one I want you guys to try on your own. It says Melissa's dining room table has hardwood around the outside, so here's the hardwood around the outside. Find the area of the wood around the edge of the table. So they do a couple things for you. They zoom in, they give you some dimensions. You can see that you have long, narrow rectangles here that are 60 by 3 inches wide and 3 inches wide, and this one's 40 by 3 inches wide. And then you also have these circular parts that when you add all 4 of them together, make one whole circle with a radius of 3. So I just wanted to point that all out to you. Now go ahead and give it a try, and we'll check back in a second to see your answer. All right, so you could have broken this down as one whole circle plus 2 long rectangles plus 2 long rectangles that are going up and down. So that would be pi r squared or pi 3 squared. This would be 2 times 60 by 30 because that's 60 by 30, and 2 times 40 by 30 because you have 2 rectangles of 40 by 30. Add it all up, you get an exact area of 9 pi plus 600 square inches, or an approximate of 628.27 square inches. All right, let's go ahead and go on to the next problem. This one is a really fun one. It's a good thinking problem, but don't worry, I'm going to do it with you guys. It says, find the area of the shaded region, assume the triangle is equilateral, and that the circle has a radius of 4 meters. So, pretty easy here. The basic formula is pretty easy. I know it's just going to be the shaded area is going to be the circle minus the triangle. Not too bad. And the radius of the circle is 4 meters, so I already know the area of the circle. It's pi 4 squared minus whatever that area of that triangle is, which I know is going to be 1/2 a base times a height. So let's figure out what the base and the height is. I'll put little parentheses here for the time being. So let's zoom in. If I have a radius, I'm going to draw a center approximately here, of 4. And it's 4 meters, but we'll come back to that later. I could almost figure out, I got part of a height there. If I was to go back down, I just need this distance to get that height. Well, what I can do here is I can draw in another radius here. That's 4. And this would be 90 degrees. And remember that these were all 60 to start with. And then this is 30, and this is 30. And so what we find out here is if I was to draw another perpendicular line, going right there, we actually find out that this line here bisects this 60-degree angle into 2 30-degree angles. And then that means that these are both 30, 60, 90s. Now this is important because if this hypotenuse of this little tiny 30, 60, 90 is 4, well then that means that the short leg is half of that because we do the hypotenuse divided by 2. So this is 2, which means that this whole height here is 4 plus 2, which is 6. Now that is important. The height here is 6. So now we just got to figure out the base. Well, we can do that as well because, again, we have a 30, 60, 90 triangle. We went from the hypotenuse to the short leg. Now let's go to the short leg to the long leg. That's just going to be 2 rad 3. And the same thing is going to be true over here. And so the whole base is 4 rad 3. All right, well, that means we're ready to calculate the area of the triangle. Because remember, we said it's going to be base times height. The base we just all decided was 4 rad 3, and the height we decided was 6. So we could simplify this a little bit. 4 squared is 16. 16 pi minus half of 4 is 2, and 2 times 6 is 12, so we can write this as 12 rad 3. And then we do have units in this problem. It was meters, so I could just say meters squared, and that's an acceptable answer. That's an exact answer. But if they wanted an approximate answer in decimal form, we could do that as well. So I'm going to do that. I just plugged that in my calculator, 16 pi minus 12 times the square root of 3. And we get that it is 29.48. And that would be, again, meters squared. So again, we have 2 potential answers here. Yeah, so that's kind of all there is to it. I know there's a little bit of work with special right triangles here that we had to recall. That's why when I taught you guys it back in chapter 8, I said, hey, we're going to be using this stuff the rest of the year. Better make sure you know it. And surprise, surprise, you're going to be using it in next year's math as well. So, awesome. So, I want you guys to try practice number 3 on your own. It's a lot simpler. It's just a rectangle inside a rectangle, so go ahead and give it a try. Okay, so that should have been pretty easy. Big rectangle minus a small rectangle to get the area of the shaded region. The big one's 12 times 10, so it's 120. The small one's 3 times 7, so it's 21. And 120 minus 21 gives you 99 square units. All right, almost done here. Summary. Explain how you could break the following image up into more manageable shapes in order to find the total area of RSTUV. Describe the segments you would draw and where you would draw them, and what smaller, simpler shapes you would then create. So again, I am not actually interested in an answer here. I'm interested in an explanation of how you would get to that answer. How would you cut this figure up so that you could find the area of it a lot easier? All right, guys, I'll see you guys on the next video.